So the more you study A-level physics, the more you understand about the world around us. And we kind of get to the point, often near the end of the course in year 13, where actually, we know that things are made out of protons and neutrons, and you've got electrons and things like this. And basically, it's these kind of three things here, protons, neutrons, and electrons, that make up all the matter that we know about, which makes up all the stars and galaxies and you and me. There is a problem though. This only makes up about 5% of everything. And so all the physics that we've been studying only accounts for 5% of what we know about in the universe. And there are other things like dark matter and dark energy that we really don't fully understand at this stage. So 5% is what we know about, but when we look at the motion of galaxies on a large scale, when we actually do the calculations, it appears that the way that they behave and the way that they rotate about certain things and the way they often collide together, there's not really enough mass that we can see. If we look at all the stars, we know the rough mass of each star. This doesn't quite account for the way that things behave in real life. And basically what we have is another sort of 25% of stuff which has mass, but we don't know what it's made out of. Maybe it is made out of this stuff that we just can't see, but maybe it's made out of other particles that we haven't yet discovered. And basically this is what we call dark matter. It's dark matter because we can't detect it, we can't see it, but yet it still has mass. So what is it? I don't know, and I don't think anybody does yet. There's all sorts of theories and kind of ideas about what it could be. So first of all, this dark matter, we know that it exists because we can see how things behave, but we can't account for it. Or maybe the fact that we've got the whole theory of gravity wrong, incorrect. So what's the rest of the universe? Well, basically, the observations that people like Hubble did, where we looked at the fact that the universe is expanding, that all kind of still stands. But when they actually looked at the rate of expansion of the universe, they found that the universe was actually expanding at a faster and faster rate. In actual fact, it's accelerating. What's causing the acceleration of the size of the universe? Well, there must be some kind of sort of energy that's kind of pushing everything apart. But it's an energy that we don't really know what it is, and just like we don't know what dark matter is, this is why we call it dark energy. And dark energy is responsible for the expansion of the size of the universe. What is it? Again, I've got absolutely no idea, but I'm sure, if you look at this video in about 10, 15, 20 years' time, we'll know a few more answers. So basically, that's it. There's loads of stuff we don't know about, but this is really exciting. The fact that we've got questions that we're asking and nobody knows the answers. There's lots of different theories, and we are really kind of sort of pushing sort of the boundaries of physics. And there's some fantastic stuff at the moment. There's things like the Higgs particle. There's things which might be maybe things like gravitons, perhaps. We've got gravitational waves. There's lots of good stuff that you can find out about. Often in the popular press on things like the BBC Radio 4, they've got some fantastic programmes, the normal news and things like, there's lots of sort of different podcasts that you can subscribe to. So I'll put a few links below this for other kind of video channels to have a look at that explore these kind of more interesting and weird areas of physics. But at the moment, the stuff you learnt in A-level physics is only about a 20th of what we sort of need to know about. So I hope that kind of makes sense, or at least kind of gets you a bit interested. And yeah, there we go. Thank you.